Hello everyone! In this video, I'll be discussing the round-robin CPU scheduling algorithm. The round-robin is a preemptive scheduling method widely used in the time-sharing systems where fairness and fast response times are important. How round-robin works? In round-robin, each process gets a fixed time slice called the time quantum. A process runs for the quantum if it still needs more CPU time afterwards. It is placed back in the ready queue to wait for its turn. We have the example of round robin and the calculations or how to calculate the round robin by the time quantum. And we are going to calculate the waiting time. So let's proceed to the example, shall we? So round robin has an executional or execute table. So P1, it's P1's turn. The time is, let's assume that they are all 0. So the time is 0 minus 4 equals 6. The remaining is 6 because the burst time is 10. So the Q now is P2, P2, and P1. So P2 is the next turn. So P2 has run 4 minus 8. 4 is the time used, and 8 is the burst time. So it's 0 because it's negative. So negative 4. So automatically it will go to 0. So Q now is P3 and P1. Turn 3 is time. Time 8 minus 12. CPU will run, yes, the P3, and remaining is 1. So the Q now is P1's turn. Turn 4. 12 minus 16. The remaining is 2. Now we are going to move on to P3. So P3 turns 5. 16 minus 17. It is automatically 0 because 17 is greater than 16. So Q now is only P1 left. So this is the turn 6. Time 17 minus 19. So the remaining is 0 because 19 is still greater than 17. That's why it's automatically goes to 0. So let's move on to the waiting time and the turnaround time, and also the Gantt chart, shall we? Let's go. As you can see, this is the Gantt chart. So all processes must go to 0 at first, and so P2 finished at time 8 because he has a burst time of 8, and 4 is the quantum. So 4 minus 8 is 0. So P3 goes next, and P1 is the last because he has the higher burst time than the others. That's why he is the last. Turnaround time calculation. Turnaround time equals finish time minus arrival time. So the MS is, or the time is 0. The arrival time is 0. So P1 has 19. 19 minus 0, 19 MS. Same goes to the others because 0 doesn't have a value to minus on. So that's why it's only neutral to minus. So 19, 8, and 17. Now let's move on to the waiting time calculation. So the formula is turnaround time minus burst time. So P1 has 19 for turnaround and burst is 10. So the waiting is 9 ms. P2 has 8, then 4, then minus, so 4 ms. P3 has 17 minus 5 equals 12.
So the waiting time of all 9, 4, and 12. So let's move on to the advantages and disadvantages and also the conclusion, shall we?
Advantages. Number 1. Every process gets equal CPU time and fairness. Number 2. No process waits forever and no starvation. Number 3. Good for interactive and time sharing systems. Number 4. Response quickly to user input. Number 5. Simple queue-based implementation. Disadvantage. Number 1. So many context switches if quantum is small. Number 2. Large quantum makes RR similar to first come first serve. Number 3. CPU overhead reduced through input. Number 4. Waiting time can be high, demanding on number of processes.